Okay, now we're going to look at solving polynomial inequalities. Let's look at example 6. We've got x squared minus x minus 6 is less than 0. Okay, now when you're solving a polynomial inequality, if possible, you should try to factor it. And that is because when it's in factored form, you can find the zeros, or also what we call the critical numbers, or critical values. Now, one of the common mistakes when people see a problem like this, and I don't quite understand logically why people think this works, but a common mistake, which I'll write in red, is people will think that because this factor and this factor, the product of it says less than 0, that somehow, magically, that means that each one of them have to be less than 0. But of course that doesn't make sense, right? Because it's not that each individual factor is equal to 0, it's that the product of them is equal to 0. Okay, when you multiply them, it equals 0. So you don't treat each one individually as the whole thing, like the whole thing is less than 0. Okay, instead what we do is we find the critical values. So the critical values are the values of x that make the entire expression x minus 3 times x plus 2 equal 0. So obviously that would be x equals 3 and x equals negative 2. So those are the critical values. Okay, and then what that allows you to do now is you can analyze what happens on a number line around those critical values. So this number line represents x values. So I'll put negative 2 and 3 on that number line. And now we know that if we plug in negative 2, we'll actually get 0. And we know that when we plug in 3, we'll actually get 0. But we don't want it to equal 0. We only want it to be less than 0, which tells me right away that negative 2 and positive 3 are not part of the solution set. But they're helpful because they separate or divide the number line into 3 different intervals: the left interval, the middle interval, and the right interval. So what we're going to do is we're going to test out different values of x within each interval to determine what the product of both of those factors is for that particular x value. So as an example, on the left interval, if you pick x equals negative 3, right? And if you plug in x equals negative 3 here and here, you'll get negative 3 minus negative 3 is a negative, and then negative 3 plus 2 is also a negative. So you're multiplying a negative times a negative, which of course we know gives us a positive product. In the middle, we can pick a value like x equals 0. So again, if you plug in 0 for x, in the left factor it'll be negative 3, in the right it'll be positive 2. Negative 3 times positive 2 gives us a negative product. And then if you plug in a number to the right of 3, like 4 minus 3 is a positive value, 4 plus 2 is also positive, so positive times positive gives us a positive product. So ultimately, the solution that we're looking for are the ones that give us products that are less than 0. And so less than 0, of course, would be the negative ones. So that's right there. So therefore, the way you would write your solution, it's already kind of set up as an interval. As an interval, you're going from negative 2 to positive 3, not inclusive. Okay, as an inequality, you would write negative 2 is less than x, which is also less than 3. One other way to interpret the solution to this problem, which I'd like to mention, is this. If you know anything about the graph of parabolas, what we know now is this. So if this is negative 2 and this is positive 3 and this is our x-axis, right? So that means our y-axis is somewhere like here. What we know about this particular parabola, which is represented by y equals x squared minus x minus 6, is that it's going to open upwards. So we know that the parabola is going to look something like this. And so when you look at this original problem, you're wanting to find out where is the parabola less than 0. In other words, where is the parabola below the x-axis, right, below the 0 line? So you can kind of visually see that the part of the parabola that's below the x-axis is this piece right here, which of course is represented by this interval, values between -2 and +3. Okay, now this is a rational inequality, and the way we approach a rational inequality is the same way that we approach a polynomial inequality. And that is, the first thing we want it to do is to make one side 0, because that allows for all kinds of comparative analysis. So I'm going to subtract the 3 to the left side, and that makes it less than or equal to 0. And then you're going to want to simplify the expression on the left into a single rational expression, which means you need a common denominator. So of course, the one on the right needs to be multiplied by x minus 5 over x minus 5. And so what that does is it gives you a common denominator of x minus 5. The left one gives us 2x minus 7. The right one gives us -3 times x minus 5, so that's -3x plus 15. So simplifying that gives us -x plus 8 over x minus 5 is less than or equal to 0. Now, in this problem, the critical values are not just the values that make the polynomial, or sorry, the rational expression equal to 0. Critical values are also x values that make the rational expression undefined. So in other words, x values that make the numerator 0 or make the denominator 0. So in this case, our critical values are going to be x equals 8 for the top and x equals 5 for the bottom. Okay, so once we've established our critical values, again, we're going to analyze the entire expression relative to what it is relative to 0. So I'm going to do a number line analysis, x equals 5, x equals 8, and I'm going to plug in values in each interval to see if the entire fraction is less than 0 or greater than 0. Okay, now one thing though before I start is that because this is less than or equal to 0, let's take a moment to just think about what that means. That means that the fraction can equal 0. So what value makes the fraction equal 0 is x equals 8. So x equals 8 has to be included as a solution. X equals 5, however, does not make the fraction equal 0. Instead, it makes the fraction undefined. So that means that x equals 5 is not a solution. So on the number line, I represent that with an open circle. Okay, so I'm going to go ahead and plug in a number to the left of 5. I'll just plug in 0 because that's easy. So the top would be 8, the bottom would be -5. So positive divided by negative gives me a negative quotient. In the middle, I'll plug in 6. So the top would be -6 plus 8, which is +2. The bottom would be 6 minus 5, which is +1. So positive divided by positive gives me a positive quotient. And then to the right of 8, I'll select x equals 9 and then plug it in. So -9 plus 8 on top would be negative, and then 9 minus 5 on the bottom would be positive. So negative divided by positive is negative. Okay, again, looking now at the fact that this is a less than or equal to 0 expression or inequality, we want the parts that are negative. So that would be this part of the number line and this part of the number line. And that's our solution. So as an interval, the left interval would be -∞ to 5. The right interval would be inclusive of 8 and going to infinity. So that's the interval notation solution. Or you could say x is less than 5 or x is greater than or equal to 8. Okay, finally we need to talk about the concept of domain. Example 8 addresses this, where they want you to find the domain of a square root expression, 64 minus 4x squared. Okay, so when we're dealing with the square root expression, what we know is that the radicand, which is the name, the fancy name for the inner part, has to end up being greater than or equal to 0. So what that means is we can actually write that out. What has to be true is that 64 minus 4x squared must be greater than or equal to 0. Okay, so you just have to solve this inequality, which we talked about in earlier examples, I think I don't remember, example 6, right? A polynomial inequality. Okay, so I think the easiest way to do this, I'm gonna go ahead and just divide out 4 on both sides, just to make the numbers a little bit more manageable. Okay, so now we got that. And then I could factor the left side, 4 minus x, 4 plus x, giving me critical numbers of 4 and negative 4. So negative 4 and 4. And then, so if I plug in negative 5, that would make it a positive times a negative. If I plug in 0, that would be 4 times 4, so that's positive. And if I plug in 5, that'll give me a negative times a positive, which would be negative. So the parts of the number line that gives me a positive, right, because greater than or equal to 0, product would be numbers between negative 4 and 4, this time inclusive of negative 4 and 4. So that tells me that my domain is all values between negative 4 and 4 inclusive. Or of course you could write it as an inequality like that.